So here we have that segment ZX is tangent to circle Y. The radius of circle Y is 4 units and ZX is 10 units. We need to find the length of segment YX. So first of all, because we have a segment or a line that's tangent to the circle, then that means that we're going to have a 90-degree angle here. Those two are perpendicular to each other. The radius is 4 units, so that means that this segment here is going to be 4 units. And then we have ZX 10 units, so 10 units. We need to find the length of segment YX, so that means this segment over here. Now this should remind you of a right triangle, so I can always draw the 90-degree angle over here too. So that means that we are given the length of the two legs and we're trying to find the hypotenuse. So here we need to say that one of the legs, ZX squared, plus the other leg, ZY squared also, that's supposed to be equal to this length, YX squared. Okay, so let's just go ahead and simplify this a little bit, and let's just say that ZX squared, that's going to be 10 squared, plus ZY squared, that's going to be 4 squared, and this one, if you want to leave it as YX squared, or if you want to change it to C squared just for simplicity, then go ahead and do so. But just keep in mind what it is that you're finding. So 100 plus 16 is going to be equal to the hypotenuse squared, and then we have 116 that's going to be equal to C squared, taking the square root of both sides. Then that means that the answer C, you can either say that this is going to be the square root of 116, or you can say that this is going to be approximately 10.8. It depends on whether you need to round it to the nearest tenth or the nearest hundredth. So that is our missing segment. So the square root of 116. Okay. Let me just change this back and say this is going to be YX. Here's the next theorem, 9-9, which is the converse of the previous one, theorem 9-8. And it says that in a plane, if a line is perpendicular to a radius of a circle at the end point on the circle, then that line is a tangent of the circle. Okay, by that we mean if we know that BD is a radius, right? And we have some line that's perpendicular to that radius at the point that's on the actual circle, on the circumference. Then, if we get to show that they're both perpendicular to each other, then we're going to be able to say that that line, that segment AC, is then a tangent of that circle. Okay, so we're going to have to show that we have a radius, and that radius needs to be perpendicular to some line, some segment at the point on the circumference. Okay, so once we show that, we get to call AC a tangent. So here's an example. Is GH tangent to the circle at point G? What does that mean? Well, it means that we have to show that segment GH is perpendicular to segment GF at point G. In other words, I need to show that angle G is a right angle. And that means that because I have a triangle here for which I have pretty much all of the measurements, I can go ahead and apply the Pythagorean theorem, or I should say the converse of the Pythagorean theorem. So first, let's go ahead and point out that FG and FK, they're both radii, so that means that they measure the same thing. So those two segments are both 6 units. Now, when it comes to identifying the different parts of the Pythagorean theorem, because I will need a squared plus b squared equals c squared, the first one to identify will always be c, because that is the hypotenuse, so that should be the longest side of my triangle. So in this case, it would be side FH. And then the other two legs, then that would be GH. So GH squared plus GF squared. So substituting the values, we have GH squared, that's going to be 13 squared plus 6 squared. Is that equal to 18 squared? 13 squared is 169 plus 6 squared, 36. And then on the right side, 18 squared is 324. On the left side, I get 205. And that is definitely not the same thing as 324. So what does that mean? Well, it means that those lengths do not make a right triangle, which means that I do not have an angle that's 90 degrees at point G. So angle G is not a right angle, and therefore GH is not tangent.